All right, we're doing section 9.3, adding and subtracting rational expressions. This goes back to our fractions, remember. Okay, so we're going to simplify some fractions. So we're going to do two things. Number one, when you have a common denominator, and number two, when you do not have a common denominator. Common denominator is easy. All we do is put these terms 1 over, so you've got 2 plus 4 over 9, which is 6 over 9, which simplifies to, 2 over 3. All right, the next one, no common denominator. We multiply by 5 over 5, 1, in the shape of 5 over 5, and this term by 1 in the shape of 3 over 3. This gives us 10 over, nope, that was wrong. Totally wrong. Apologies. I flipped those. Okay. So I multiply the first term by the denominator of the second term. And I multiply the second term using the denominator of the first. This is going to give me a denominator of 15. So I end up with 6 over 15 plus 5 over 15, which then becomes 6 plus 5. Now that I have a common denominator, I can put them together, and I end up with 11 over 15. Now, subtraction, same basic concept. This has a non-common denominator, but they both have 6 in them. This is 6 times 5, and this is 6 times 3, which means that this side needs a 5 over 5, and this one needs a 3 over 3. This gives us a common denominator of 90. Believe it or not, 3 times 30 is 90. Okay. So, this gives us 55 plus 21. Apologies, not a plus. That should be a minus. 55 minus 21 over the new denominator of 90. So 55 minus 21 is going to be 29. Nope, 34. $55 minus 20 would be 35, minus one more, so 34. All right, so common denominator. This is going to be very important as we proceed. The process of adding and subtracting rational expressions follows the same principles as adding and subtracting fractions. Remember that it is always a good idea for your results to be completely simplified, which means you're going to have to cross out any common factors. To add or subtract rational expressions with different denominators, this is critical that you remember. You must first convert all terms to equivalent terms, having a common denominator. This is called the lowest common denominator, and it is made up of the lowest common multiples. Okay, number 4. Fourth slide is what that means. Sorry about that. Okay, we're going to add these two together. They have a common denominator right now, so I can just add the tops. So I end up with x minus 9 plus 3x plus 1, all over the common denominator. Well, 3x plus x gives me 4x. Negative 9 plus 1 is minus 8. But notice, to put this in lowest, simplest terms, I factor out the 4, and I'm left with x minus 2. So my x minus 2 will cross out, because they're factors, and I'm left with just the 4. Now remember, this also, x cannot equal 2. Okay, so we're looking for a lowest common multiple. The smallest number that each of these is a multiple, or is a multiple of each of these. In other words, these are all factors of the smallest number. So when I get them all factored out like this, 27 being 3 cubed is my highest number of 3s. There's 3 in there. So I have 3 cubed. For the 2's, my largest is 2 squared. For the a's, my largest is a to the 4, and b's, the largest is squared. So 3 to the 3 is 27. Times 4 is 108. A to the 4, b squared. That is my lowest common multiple, the smallest number that all of these 3 terms are factors of. Now, find the I'm sorry, I'm trying to think about this. That was wrong. I apologize. Okay, find the lowest common multiple of these. Okay, so I factor each one, and I'm looking for a number that has all of these, a minimum number of each of these factors in it. So I'm going to have x. I'm going to have x minus 4, because that's right here, and x minus 2. So it's going to be x minus 4, and x minus 2. That is my lowest common multiple. Okay, so now I have to add these. So I have to get a common denominator. To do that, I have to find the lowest common multiple of the 2 denominators. If I factor my 2 denominators, I get x plus 3 and x minus 2, and then I get x minus 2 squared. Got to watch out for that squared. Okay, the common is x plus 3 and the x minus 2 squared. Okay, that's my lowest common denominator, lowest common multiple. Okay, now what I need to do is multiply each term, that term, and then this term, by what is missing in their denominator. Well, 5x is missing that term, sorry, not the 5x itself, but this term is missing an extra x minus 2. So I'm going to have to multiply this by x minus 2 over x minus 2. And my x plus 7 term is missing the x plus 3. So I multiply it by x plus 3 over x plus 3. What that's going to do is give me a common denominator of x plus 3 x minus 2 squared. And the numerator is going to be, well, I have to distribute the 5x in. So I get 5x squared minus 10x plus x plus 7 times x plus 3. That's x squared plus 7 and 3 is 10x plus 7 times 3 is 21. And if I combine those all together, notice I have a plus 10x and a minus 10x. So those are going to cross out. So I'm going to end up with 6x squared. That's the x squared and the 5x squared. And then just plus 2. And this is all over the x plus 3 x minus 2 squared. And that's my final answer. All right. Now we have, oh, this is exchange. Okay, this slide would just be this demonstration you what I did, of what we just did. Okay. If the denominators are opposite, such as y minus 2 and 2 minus y, these are not conjugates, these are opposites. Notice the y is positive and then it becomes negative. The 2 is negative and then it becomes positive. That's what makes these opposites. A common denominator can be obtained by multiplying negative 1 in both the numerator and the denominator. All right, an alternative approach involves factoring out a negative 1 from one of them. When a complex fraction contains sums or differences, an alternative method of simplifying is to multiply both its numerator and denominator by the term's lowest common denominator. Well, you'll see what that means as we work through a few. Now, for adding or subtracting, step 1, find lowest common denominator. Step 2, read outright each term as an equivalent fraction with the lowest common denominator. Add or subtract the numerators and place the results over the denominator, which is our lowest common denominator, and simplify the resulting expression. All right, so here. Alrighty, whoops. This is our problem right here. And this is equal to, well, first, we're going to get rid of these two little denominators. If I multiply the top and the bottom by x squared, that's what you see going on right here, then when I distribute this in, I'm going to get a 25x squared, and the x squared is going to cross off and I just have 1. No fractions. I have a 5x squared, and one of the x's crosses off, so I'm left with an x on the bottom. Again, yay. All right, now, at this point, you still need to simplify. Notice that if I factor an x out of the top, I get 5x plus 1. If I factor the denominator, that's a difference of squares, so it gives me the conjugates 5x plus 1 and 5x minus 1. So I can now simplify, and I end up with x over 5x minus 1. So that would be my simplified complex fraction. All right, so that's what you're seeing here. Oh, I'm sorry. No, you aren't. This is a different method. This got me into a common fraction so that my numerator is just one fraction and my denominator is one fraction instead of a constant and a fraction. Then I can flip and multiply these. So this would give me 5. Okay, I apologize. My hand hit the little record button. I hate it when it does that. Let me go back. There we are. We have 5x plus 1 over x times, flip the denominator, x squared over 25x squared minus 1. Okay, now I can factor the denominator. First off, I can see I can get rid of this x by getting rid of that exponent, and that's just going to have the 1x left on it. Okay, so now I have x times 5x plus 1 in my numerator. I factor my denominator into 5x plus 1, 5x minus 1. Cross out the common factor, and I have x over 5x minus 1, which is what I got the other method. Okay, oops. All right, now, the harmonic mean of n values, so I have n separate values, is the quotient of the number of values, that's my n. So if I had 7 values, that would be 7. And the sum of their reciprocals. So now my denominator, look at this big long thing. Okay, so I have 1 over x1 plus 1 over x2, whatever these values are. All right, so that is how we find a harmonic mean. All right, the Bogmans traveled the same distance on each of the 3 days of their family trip. They averaged 50 miles an hour traveling the expressway the first day, 35 miles an hour in the mountains the second day, and 55 miles an hour on the way home. What was their average speed throughout the trip? Since the distances are equal, find the harmonic mean. Okay. We know they're equal because it actually does say so. It says they traveled the same distance on each of 3 days. So the distances are equal. So we find the harmonic mean by, we have 3 terms. Oops, sorry about that. Not a highlighter. There we go. So we have 3 terms. We divide it by 1 over, the first one is 50, plus 1 over 35, plus 1 over 55. So to do this, we're going to need to turn the denominator into a common fraction. That's going to be my easiest way to do this. So to do that, I see I have 7 times 5, I have 10 times 5, and I have 11 times 5. So I need 10 times 7 times 11 times 5. All right, so that's my new denominator. 10 times 7 times 11 times 5. My numerator, on the other hand, the 50, I have the 10 and the 5 require the 7 and the 11. So I have 77. The 35 has the 7 and 5 and requires the 10 and 11, which gives me 110. The 55 has the 11 and the 5, is missing the 10 and the 7, so I have a 70. And this is 3 over all of that. So I now have 3 over, well, actually I'm going to flip and multiply. So I'm going to have 3 times, I'm sorry I ran out of room. Here, I'll stick it up here. 3, whoa. Gosh darn it, I did it again. What did I do here? Okay, I think it was this. There we are. Okay. I got to use my little Protecto pad. 3 times. Now, 77 plus 70 is 147. Plus 110 is 247, 257. Times the 257 is going to go on the denominator. The numerator is 70 times 11 times 5. So 70 times 55. So I'm going to whip out my calculator because I'm not going to do that one in my head. 70 times 55, and I get 3,850. So the first thing I'm going to do now is see if 257 is divisible by 3. And it's not. Okay, let's see if 3850 divided by 257 is a whole number. And it's not. Okay, now I'm going to convert it back to fraction. And that'll tell me if it reduces. It does not. Okay, so my answer is going to be 3,850 times 3. So my final answer is going to be 11,550 over 257. That is an exact value. The decimal equivalent would be 44.94. All right. Last slide. They averaged 50, 35, and 55. Oh, here it is, finding the average mean, and there we go. Da-da-da-da, and we're done. All right, there's your homework. Have fun.